I have some electricity issue from last night. Since last night we don't have electricity here. If I got disconnected from during the class, please don't mark me absent.
Okay, you were present in the last class lecture?
Mm. What did you say, ma'am?
I'm saying, were you present in the last lecture?
Yes, I was present in last lecture.
Your attendance is
My attendance is short, ma'am. I know about that.
okay.
Thank you, ma'am.
Okay, in the previous lecture, we started the topic 12.5 lines and planes in the space, and we derived equation of the lines in space. We basically derived three forms for the lines. One is vector equation of the line, second one is symmetric, second one is parametric equation of the line, and the third one is symmetric equation of the equations of the line. And you have seen how to find uh, how to check the what are the skew lines and how to check whether the lines given are skew or not. If they are not parallel and they do not intersect, then the lines are called skew lines. So that's all we did in the last lecture, and today we will do derive equation of the planes in the space. And so how do we define? Uh, as we did to determine equation the line in space, we need a point and the direction of the line L. That the point P that is contained in the line that lies on the line and direction of the line which is given by a vector parallel to the line. Now we will derive the equation of the plane, and same we need a point that lies on the plane and the direction of the line of the plane. So which vector determines the direction of the plane, whether it's this vector or this vector. These all vectors lie on the plane. So which vector we will take to uniquely determine the direction of the plane? Can you see anything? Can you say anything about it?
मैम हर प्लेन का अपने रेफरेंस के हिसाब से नहीं होगा?
That's what I am asking. Which vector should we take to determine the direction of the plane? Because there are infinitely many vectors to which the plane is parallel. So do we take a vector which is parallel to the plane or something else?
मैम 2 वेक्टर्स नहीं लगेंगे?
नॉर्मल वेक्टर ले
Normal vector, if we take a vector and we say that, let's call it as a vector n, and we say that we have to find the equation of the plane which is perpendicular to this vector, then we will uniquely determine a plane, this vector only, then we will appropriately mention the direction of the plane P. Let's call it as plane P. And if I say the point P, then I will uniquely determine the plane P. That is, it is perpendicular to the vector n and the point P naught lies on the plane. Otherwise, if I don't mention the point, it will be this vector, it will be this plane, this plane. These all planes are perpendicular to the vector. But if I want to uniquely determine the plane, that is a unique plane, then I have to mention the point P naught as well. That is, the plane passes through the point P naught and it is perpendicular to this vector n. And this vector n is called normal to the plane. So that's why we're not saying that the plane is parallel to this vector. Because in that case, if I say that the plane is parallel to this vector, then I can make infinite and passes through this point, then I can take infinitely many I can form infinitely many vectors that are parallel to this vector and passes with the point P naught. So for the direction of the plane, I have to take a normal vector and a point. So I will say that the plane is determined if I have a point that lies on the plane P and a normal vector with coordinates A, B, and C perpendicular to the plane. So now I am going to derive the equation of the plane P. This is my normal vector, and here is my point x naught, y naught, z naught. So how to determine equation of the plane? How to proceed? How to proceed with it? Anyone? If I take any vector on the plane, what would be the relationship between the vector and the normal vector?
मैम वो perpendicular
मैम perpendicular होंगे
Perpendicular होंगे, because normal to the plane means this vector n is normal to the plane means this vector is perpendicular to all the vectors lying on the plane. So if I take any vector, let's form any vector by taking any point on the plane, an arbitrary point on the plane, arbitrary point, that is no condition on that point. So I join this P naught with P. Now I form a vector P naught P and the normal vector. So what is the relationship between vector P naught P and normal vector? They are perpendicular each other. When they are perpendicular to each other, so what is the dot product between them? The dot product between them is 0 because cos of 90 degree is 0. So it makes this dot product equal to 0. So now I'm going to take the dot product. What is P naught P? It is equal to x minus x naught, y minus y naught, z minus z naught, right? And vector, normal vector is given to me with components A, B, and C, and the dot product is equal to 0. Now what is the dot product? I have to multiply it component wise. I have to sum of the product of the corresponding components, x minus x naught multiplied by A, or I can write it A into x minus x naught plus B, y minus y naught plus C, z minus z naught is equal to 0. Now this is my equation of the plane that passes through the point P naught, x naught, y naught, z naught, and with the normal vector n. Okay, तो हमें किसी भी plane की equation determine करने के लिए we will be given a point which lies on the plane and a normal vector to the plane. So I can simplify this equation. I can simplify it ax plus by plus cz plus d is equal to 0. What is my d? D is minus ax naught minus by naught minus cz naught. Because a, b, c are some constant, they are given, and x naught, y naught, z naught is also a constant. So it means equation of the plane is this. If I simplify it, I will get this equation. So any linear equation in x, y, and z with not all a, b, and c 0 represents equation of a plane. This represents equation of the plane as I told you before. So how to determine equation of the plane? I have done all this. So example 4. Find an equation of the plane through the point 2, 4, minus 1 with the normal vector this. Okay, now I am given equation of the plane x minus x naught plus by minus y naught plus c z minus z naught is equal to 0. Okay, substitute. This is my n, x minus 2 plus 3 y minus 4 plus 4 z plus 1 is equal to 0. So simplifying it, I will get 2x plus 3y plus 4z is equal to minus 4 minus 12 minus 14 plus 4. Minus 4 and minus 12 minus 16 and plus 4 minus 12. So it is equal to 12. So this is my simplified of equation of the plane with the given condition. Okay, very simple to find. So in the next, I have to find the intercepts and sketch the plane. So first I will find the x-intercept. What happened? X-intercept. For x-intercept, I have to put x-intercept is a point where it is the plane is crossing, my surface is crossing the x-axis.
Equal to 0.
And when it crosses the x-axis, at that point, both y and z are 0. So I will put y and z equal to 0. I will get 2x is equal to 12. This implies that x is equal to 6. So 6 is my x-intercept. Similarly, I can find the y-intercept and the z-intercept. For x-intercept, y-intercept, I have to put x and z both equal to 0. And when I put x and z both equal to 0, I will get y is equal to 4. And for z-intercept, I have to put both x and y equal to 0. So this implies that z is equal to 3. So 3 is my z-intercept. Now I have to draw the plane. This plane crosses all the three axes. So this is the sketch of the plane. Basically, this is the plane that you see in your first octant, that it is passing through, and rest of the plane lies, basically plane lies in the other octants. This is the like a sheet of paper covering this and crossing these axes. Okay. Now I have done this one. Okay, now this question. Example 5, find an equation of the plane that passes through the points P, Q, and R. Now we are given 3 points, no normal vector. How will we determine the direction of the plane? How can we get the normal vector to this plane, to the required plane? What will we do? We are given 3 points. Can we determine normal vector from these 3 points? Yes, anyone?
क्रॉस प्रोडक्ट से
Yes, cross product of what? I have 3 vectors that lie on the plane. If I form any 2 vectors with these 3 points, I can form this vector, I can form this vector, PR, PQ. Now I have 2 vectors, and if I take the cross product of these 2 vectors, so by definition of the cross product is a vector that is perpendicular to both, to the plane containing the vectors PR and PQ. So I can determine the vector n by taking the cross product of these 2 vectors, and vector n, I can take it equal to PR, I can take PR, I can take PQ, so anything I can take, or QR or RQ or RP, okay, but I have to involve all the 3 vectors, all the 3 points for the formation of these 2 vectors. Okay, the vector n is equal to this one, and by taking any point, taking point P, Q, and R, I can determine the equation of the plane. So these are the vectors P, Q, and PR, and the vector n is formed by taking the cross product. This is how you take the cross product, by evaluating this determinant, and then taking any point. You can take the point P, you can take the point Q, and you can take the point R. The equation remains the same if this equation of the plane is a unique in this case. This is not the case for the equation, the line that is not unique. So this is my equation of the plane. कोई भी पॉइंट आप इसमें पुट कर लें, कोई फर्क नहीं पड़ेगा। ओके, नाउ एग्जांपल 6, find the point at which the line with the parametric equation this intersects the plane this. Yes, how will you proceed? We have to find the point of intersection of the line and the plane. Can the intersection of a line and a plane can be a line? क्या एक
मैम
लाइन
वो
फिर प्लेन
लाइन
की इंटरसेक्शन? जी,
मैम लाइन तो तब होगी जब वो लाइन प्लेन पे हो सिर्फ।
yes, exactly. If the line lies on the plane, then the intersection of the line and a plane is a line itself. So now we are given that we have to, is the line lying on the plane? Can we see? क्या यहाँ से ये नजर आ रहा है कि लाइन प्लेन पे लाई कर रही है? We will find the vectors. Also, if the line is parallel, then we will not find, we cannot find the, this is my vector v to which the line is parallel, 3 minus 4 1, and the normal vector is 4 5 minus 2. So what is the relationship between v and n? The dot product is not 0. It means the vector v is not perpendicular to the vector n. So it means the vector, the line is not parallel to the plane or is not lying on the plane. ठीक है, तो यहाँ से ये पता चल गया. Now we have to find the point at which the line with the parametric equation intersects the plane. ये क्या होगा? How to determine that point? We suppose that the point is xyz lies on the plane. Then we will put this point in this equation of the plane. Basically, simultaneously solve this equation. This is 2 plus 3t plus 5 minus 4t minus 2z, 5 plus t is equal to 80. Now I will simplify this equation and find the value of t from it. And then I will simplify this equation and the value of t is minus 2. So t is equal to minus 2, put it in the equation of the parametric equation of the line. I will get that point, which is the point of intersection of the line and the plane. So if the line does not intersect the plane, it means the line is parallel to this plane, is not crossing the plane. So what will be the situation then? फिर हम t की वैल्यू कैसे, यहाँ से t की वैल्यू क्या आएगी अगर मैं इस पॉइंट को इसमें पुट करूँ? If the line is parallel to the plane, if I put the point in the plane, what will I get? Yes, student, please wake up, all of you.
मैम वो तो
मैम
इंटरसेक्ट
टी
ही
के
नहीं
लिए
कर रहे.
निकाल के
Because I
एक्स वाई
will
जी
be
के अंदर
asking
पुट
this
कर देंगे.
question in the exam. Yes, when we will put the point in the plane, what will I get?
-2.
No,
मैम
if
लेफ्ट
I'm,
हैंड साइड इज
my
इक्वल टू
question is
राइट हैंड
different.
साइड.
मेरा क्वेश्चन डिफरेंट है. मेरा क्वेश्चन ये है कि इफ आई एम सेइंग, ये क्वेश्चन सॉल्व हो गया, एग्जांपल 6 सॉल्व हो गई है. अब मुझे इस तरह से एक लाइन की इक्वेशन गिवन हो जो कि इस प्लेन के पैरेलल है. इफ द लाइन इज पैरेलल टू द प्लेन एंड आई पुट द पॉइंट इन द प्लेन, तो क्या बनेगा? फिर टी की वैल्यू निकल आएगी, नहीं निकलेगी, क्या चीज बनेगी?
मैम टी की कोई कॉम्प्लेक्स वैल्यू?
स्क्वायर तो आना नहीं है, स्क्वायर तो आ नहीं रहा क्योंकि लीनियर है सारे, तो कॉम्प्लेक्स तब आएगा जब आपको स्क्वायर रूट लेना होगा।
मैम एक्स वाई या जी में किसी की वैल्यू 0 होगी।
तो जब इसमें ये t की वैल्यू, ये पॉइंट इसमें पुट कर दिया, तो फिर t की वैल्यू क्या डिटरमिन हो जाएगी या नहीं होगी? क्योंकि मैं कह रही हूँ कि जब एक लाइन, व्हेन अ लाइन इज पैरेलल टू अ प्लेन, देयर विल बी नो पॉइंट ऑफ इंटरसेक्शन, बट स्टिल आई एम सब्स्टिट्यूटिंग दैट पॉइंट इन द प्लेन, तो उसमें t की वैल्यू क्या होगी? t की वैल्यू डिटरमिन हो जाएगी, नहीं होगी, कंट्रोवर्सी आ जाएगी, क्या होगा?
मैम टी कैंसिल हो
नहीं
जाएगा।
होगी सर।
नहीं determine.
मैम
t
टी
कैंसिल
कैंसिल
हो
हो
जाएगा,
जाएगा।
और साथ में इक्वेशन विल नॉट बी सेटिस्फाइड, t कैंसिल हो जाएगा और इक्वेशन
मैम
सेटिस्फाइड
वेरिएबल ही
नहीं हो
खत्म हो
जाएगा।
जाएगा।
लेफ्ट हैंड साइड इज नॉट इक्वल टू राइट हैंड साइड, लेफ्ट साइड पे 2 आ जाएगा, राइट साइड पे 4, या इस तरह की कोई सिचुएशन होगी कि आपको पता चल जाएगा कि इस पॉइंट को इस लाइन में पुट करने से कोई इक्वेशन आपके पास सोल्यूशन नहीं आ रहा। सो इन दैट केस यू विल से दैट दिस पॉइंट डज नॉट लाई ऑन द, देयर इज नो पॉइंट ऑफ इंटरसेक्शन द लाइन एंड द प्लेन। और अगर लाइन प्लेन के ऊपर लाई कर रही होगी और मैं लाइन की इक्वेशन पुट कर दूंगी प्लेन में, देन व्हाट विल आई गेट?
एक कांस्टेंट नंबर इज इक्वल टू कांस्टेंट नंबर।
फिर इक्वेशन सेटिस्फाई हो जाएगी, बट ऑल वैल्यूज ऑफ t वुड बी कैंसल, t सारा कैंसिल हो जाएगा, लेकिन ऐसे आ जाएगा कि 2 इज इक्वल टू 2, 4 इज इक्वल टू 4, या 0 इज इक्वल टू 0, राइट हैंड साइड इज इक्वल टू लेफ्ट हैंड साइड। So it means the equation is satisfied for all values of t. So it means the line is lying on the plane. If there is a line is intersecting the plane at a single point, then I will get a unique value of t like this. And if the line is lying on the plane, then the equation is satisfied for all values of t, that is t is cancelled, and we get 0 is equal to 0 or 2 is equal to 2, whatever. And if the line is parallel to the plane, and then I put the equation of the line in the plane, then the equation will not be satisfied. That is, all the terms would be cancelled, and you will see that the equation is not satisfied for any value of t. That means the line is not intersecting the plane, right? All of you got this point? Okay. Example 6.
मैम
Yes.
मैम ये जो हमने पहले वेक्टर निकाला था, तो फिर वो ना निकाल कर चेक करें कि पैरेलल है या परपेंडिकुलर है,
जी
हमें वो टी की वैल्यू इंडिकेशन दे देगी।
जी टी की वैल्यू दे देगी, तो वैसे मैं आपको बता रही थी कि इसको देख के
ओके
भी आप बता सकते हो, ठीक है? So parallel planes, two planes are parallel if their normal vectors are parallel, and we can easily see by looking at the equation of the planes whether they are parallel or not. That is, we are given the equation of the planes. So the normal vector to this plane is very simple, the coefficient of x, y and z, 1, 2, minus 3, and the equation, a normal vector to the second plane is 2, 4, minus 6. Now since this n2, if I multiply n1 with 2, I will get n2. So both the vectors are constant multiple of each other. So both the vectors are parallel. Since the normal vectors are parallel, so their planes are also parallel. So we can decide by looking at the equation of the planes that the planes are parallel or not. So if the two planes are not parallel, then they will intersect, and their intersection is a straight line. Okay, intersection of two planes is a straight line, just as the intersection of two straight lines is a point. Similarly, intersection of two planes is a straight line, and the intersection of two planes can be a plane as well when the two planes are overlapping. In that case, intersection is a plane itself. So now here we are discussing about the when the planes are not parallel, then obviously they will intersect at some line, and we have to find that angle between the two planes, and we have to find the line of intersection of the two planes. Okay, now we have two questions. One question is find the find the angle between the two planes, and find the line of intersection of the two planes if the planes are not parallel. If the planes are parallel, obviously their angle is 0 degree and there will be no intersection. So how to find the angle between the two planes? It is the angle between their normal vectors, and to find the angle between two vectors is very easy. We take the dot product, simply n1 dot n2, and find the value of. So the question is, find the angle between the planes this and this, and find symmetric equation, the line of the intersection of these two planes. Now we have two questions. So the normal vector to the first plane is 1, 1, 1, and the normal vector to the second plane is 1, -2, 3. So n1 dot n2 is equal to n1 magnitude cos theta. So this implies that cos theta is equal to n1 dot n2. So what is n1 dot n2? 1 into 1 -2 plus 3 divided by magnitude of n1, 1 square plus 1 square plus 1 square square root, and n2 magnitude is 1 square plus 2 square plus 3 square. Simplify it and then take the inverse, cos inverse. You can write it in the degrees or in the radian. Okay, very simple. Now the real thing is to find the symmetric equation for the line of the intersection of these two planes. That these two planes are intersecting, and they are intersecting in a line. This is the intersection of the planes. So how to find equation of this line L? This is the normal vector to the first plane. This is the normal vector to the plane N2. So to find the line of intersection of the plane, we need a point and we need a vector to which the line is parallel. How to find the vector V which is parallel to the line L? The line L is lying on both the planes N1 and N2. How to find? So first my question is how to find a point P naught that lies on both the planes and the line L. If the point P1 lies on both the planes, it means it lies on the line. अगर एक पॉइंट है जो कि दोनों प्लेन्स पे लाई कर रहा है, इसका मतलब है वो दोनों के इंटरसेक्शन में है, तो ऑब्वियसली वो लाइन एल पे ही लाई करेगा. So we have to find any point on the that lies on both the planes. So what will we do? What will we do to find the point of intersection of the two planes? At any point on the line L. कैसे करेंगे?
मैम साइमल्टेनियसली सॉल्व करेंगे.
Simultaneously solve कर लेंगे, but we have three unknowns. That is 3 unknowns and 2 equations. We have 2 planes and 3 unknowns. So we cannot determine them uniquely. So what will we do? We put z is equal to 0 in both the equations. X plus, it becomes x plus y is equal to 1, and the second equation becomes x minus 2y is equal to 1. Now simultaneously solve it. So what will be the point that I will get? Is minus plus minus. So I will get y is equal to 0, my point. I'm going to put x, y is equal to 0, x is equal to, so this is my point 1, 0, 0. This is a point that lies on both the planes. It satisfies both the planes. Satisfy कर रहा है ना ये 1, 0, 0 को इसमें put करें. Equation is satisfied.
Excuse me, ma'am.
जैसे हम करते थे ना लाइन में, कोई भी पॉइंट फाइंड करना था लाइन में, तो हम क्या करते थे, y को पुट कर दें 0 और x की वैल्यू निकाल लें, या x को 0 पुट कर ले तो y की वैल्यू निकाल लें. तो z को अगर 0 ना पुट करते तो इसको साइमल्टेनियसली हम सॉल्व करके एक यूनिक पॉइंट ना आता हमारे पास, फिर उसमें z आर्बिट्रेरी होता या y आर्बिट्रेरी या x आर्बिट्रेरी, क्योंकि 2 इक्वेशंस है 3 अननोन्स है. ठीक है, तो इसलिए किसी एक को 0 पुट करें एंड देन फाइंड द अदर 2 वैल्यूज, या 2 को 0 भी रख सकते. 2 को 0 जरूरी नहीं कि साइमल्टेनियसली 2 0 भी आ जाए. जी ये फातिमा आप क्या कह रही थी?
वो आपने एक्सप्लेन कर दिया कि x या y को भी 0 पुट कर सकते हैं।
हाँ, एक्स और वाई को भी कर सकते हैं, ये तो अपनी आसानी के लिए करते हैं ना हम। लेकिन ये पॉइंट दोनों को सेटिस्फाई कर रहा है। ओके, पॉइंट तो हमें मिल गया विच इज द पॉइंट ऑफ इंटरसेक्शन ऑफ द प्लेन, सो इट मींस इट लाइज ऑन द लाइन एल। तो पॉइंट हमने इसको अपने पास संभाल के रख लिया। अब मसला है वेक्टर v का, तो विच द लाइन इज पैरेलल। लाइन लाई कर रही है ऑन द प्लेन p1, it means the line L is perpendicular to n1 and the line L is lying on the plane, the other second plane. So it means the line L is perpendicular to n2. Now I have to find a vector v which is perpendicular to both the vectors n1 and n2. And for this, again, I have to take the cross product of n1 and n2. समझ आ रही है कि क्रॉस प्रोडक्ट लेना क्यों जरूरी है? क्योंकि लाइन L is perpendicular to both the vectors n1 and n2 because it is lying on both the planes. So it means a vector v which is parallel to the line L is perpendicular to both the vectors n1 and n2. And to find the vector v, you have to take the cross product of n1 and n2. So we will take the cross product. First I will find the any point on the line L and then take the cross product of the two vectors. This is my vector to which the line is parallel. Now I can easily determine the equation of the, I have to determine the symmetric equation. So put the values in the symmetric equation of the line and I will get the equation of the line. Okay. Now this is the,
ये लॉजिक
जी
समझ आई, v परपेंडिकुलर क्यों होगा, मतलब उन दोनों प्लेन्स के वेक्टर के?
देखें लाइन L जो परपेंडिकुलर है n1 and n2 के, लाइन L समझ आ रही है कि n1 और n2 दोनों के परपेंडिकुलर है।
नहीं मैम, ये नहीं, यही लॉजिक नहीं समझ आई।
लाइन L क्या है इधर? इट इज द इंटरसेक्शन, ये दोनों प्लेन्स पे लाई कर रही है क्योंकि इन दोनों की इंटरसेक्शन है। तो n1 vector, normal vector, how we define the normal vector n1 is the plane. तो n1 vector प्लेन के नॉर्मल है, इसका मतलब है जो चीज भी, जो लाइन, जो वेक्टर भी प्लेन p1 पे होगा वो उसके परपेंडिकुलर है, ठीक है। और लाइन L चूंकि प्लेन p1 पे लाई कर रही है इसलिए नॉर्मल वेक्टर n1 के परपेंडिकुलर है। और इसी तरीके से लाइन L लाई कर रही है प्लेन p2 पे भी, तो ये परपेंडिकुलर है टू द नॉर्मल वेक्टर n2। ये समझ आ गई है कि ये भी नहीं आ रही?
यस मैम, ये समझ आ गई।
तो अगर ये समझ आ गई है तो कोई भी वेक्टर जो कि वो है वो n1 और n2 दोनों के परपेंडिकुलर होगा। तो वो वेक्टर
सही
हमें
हो गया
कैसे
मैम, थैंक
वो वेक्टर हमें कैसे मिलता है? वो n1 और n2 के क्रॉस प्रोडक्ट से मिलता है, क्योंकि क्रॉस प्रोडक्ट का मतलब है कि ऐसा वेक्टर जो कि दोनों के परपेंडिकुलर है, n1 और n2 दोनों के परपेंडिकुलर है, ठीक है। तो ये देखिए कि ये लाइन जो है L है, ये इंटरसेक्शन है दोनों प्लेन्स की, यानी दोनों प्लेन्स पे लाई करी, दोनों प्लेन्स पे लाई करी, इसका मतलब है दोनों के नॉर्मल वेक्टर के परपेंडिकुलर होगी। हम नॉर्मल वेक्टर को तो हमने ऐसे डिफाइन किया ना कि जो भी नॉर्मल, जो भी चीज, जो भी लाइन है जो प्लेन पे लाई कर रही है वो इस वेक्टर के परपेंडिकुलर है, वो वेक्टर भी जो लाइन है। तो इस चीज से हमने ये चीज निकाली है। ओके जी, अब आगे एक पॉइंट
सही
और मैं
है
एक्सप्लेन
मैम।
करना चाह रही हूँ, वो ये है कि x minus 1 is equal to 5, I can write it as y minus 2 and y minus 2 is equal to z over 3. Now I have written this equation separately as two linear equations because it represents two linear equations. And as I told you that a linear equation in x, y, and z represents a plane. So it's a plane. So it's a plane. So it means the intersection of two linear equation. When I see the two linear equations combined, I will say that they represent a line because their intersection is a line. And this is what the symmetric form tells us. That is, it represents two linear equation and each linear equation represent a plane. It means this line is actually the intersection of these two planes, this plane and this plane. That's the point over here. Okay, now the last topic is, this is the point of intersection of this. find a formula for the
Excuse me,
distance. जी
मैम वो मेरा लास्ट क्वेश्चन, वो पिछले लास्ट क्लास से क्वेश्चन था कि हमने x को y के इक्वल रखा है और y को z के, तो x को भी रख सकते हैं z के इक्वल, वो भी एक प्लेन आएगा,
वो भी आ सकता है।
तो ये 3 प्लेन आ जाएंगे फिर।
बेसिकली वो जो 3 प्लेन कहना चाहें तो कह सकते हैं, लेकिन वो इन दोनों को कंबाइन करें तो x z के इक्वल ही आ जाता है ना, तो वो इसी में से ही एक निकला है।
ओके मैम।
x y के इक्वल है तो y वाला z के इक्वल है, तो x वाला z के इक्वल भी होगा, वो उसी से ही निकला है। वो यूनिक नहीं होगा ना, वो इन दोनों इक्वेशंस को ही बेसिकली आपने मल्टीप्लाई करके ऐड कर दिया, ये काम नहीं किया। जैसे दो
ओके मैम।
इक्वेशंस को जब हम सॉल्व करते हैं तो उन दो इक्वेशंस को किसी चीज से मल्टीप्लाई करके ऐड करते हैं, तो वो बेसिकली कोई अलग से कोई इक्वेशन नहीं होगी, उन्हीं दोनों को ऐड सब्ट्रैक्ट करने से आपके पास आ रही है ना। तो इस तरीके से इन दोनों इक्वेशंस को अगर हम देखें तो ये x वाला y के इक्वल है, y वाला z के, तो इसका मतलब x वाला z के इक्वल है, तो इससे तो यही निकल है, तो इसको वो यूनिकली नहीं होगी वो इक्वेशन, अलग से उसकी आइडेंटिटी नहीं होगी। ठीक है, okay ji, now we have to determine, we have to derive a formula for the distance d from the point p1 x1 z1 to the plane this. Okay, obviously this point is not lying on the plane, so if it is lying on the plane, it means the distance between the point and the plane is 0. So what should be the distance between the point p1 to the plane? We draw a perpendicular from the point on the plane, so this is the distance, and you will observe if it is the distance, it lies along the normal vector. ये normal vector के along होगा क्योंकि ये perpendicular है plane के। ठीक है, तो ये formula, I'm not going to derive the formula for you, you will have to see this formula. It is all done here in the slide. So this is my formula that I have to, this is my formula, and my equation of the plane is this, and the point is this. So in the formula, what I have to do, I have to put this equation, this point in this equation, that is this one. In place of x, y, and z, I have to put x1, y1, z1, that is the point, this point, and then take the square of a plus b square plus c square in the denominator. That's the formula for the distance of a point from the plane, and the point lies outside the plane. Now the question is, find the distance between the parallel planes. What will we do? How to find the distance between two parallel planes? Obviously the planes are parallel. If they are not parallel, means they are
मैम
intersecting, and
इनका
the distance,
क्रॉस प्रोडक्ट 0 होता है।
the planes are parallel. Okay, planes का कि नॉर्मल वेक्टर का ही
तो
लेंगे ना क्रॉस
उसी से
प्रोडक्ट।
निकालेंगे।
डिस्टेंस निकालना है हमें। हमें डिस्टेंस फाइंड करना है। We have to find the distance between two parallel planes. If the planes are intersecting, if the planes are not parallel, it means they are intersecting and the distance is 0. But since the planes are parallel, अभी हमने फार्मूला किया है, फार्मूला हमने क्या किया है, the distance between a point and a plane. तो यहाँ पे उसको कैसे यूटिलाइज कर सकते हैं? The distance between two parallel planes. So what will we do? We find a point on the plane. On any end of the plane, I find a point by putting y and z both equal to 0. I can put x and z equal to 0. I can put x and y both equal to 0 to get a point. So when I put y and z equal to 0, I will get 10x is equal to 5, which is x is equal to 1/2. So any point on the plane, the first plane is this. Now I find the distance between this point and this plane, and which is this plane and this point, by using that formula, which is just substitute this point over here, mod of this, and then 5 square plus 1 square plus 1 square. This one. Just determine this value, and this is the distance between two parallel planes. कि आपने किसी कोई एक प्लेन लेना है, उसमें कोई भी एक पॉइंट फाइंड कर लें, और पॉइंट फाइंड करने का the easiest way to find a point on the plane is just find x intercept or y intercept or z intercept, anything you like. ठीक है, ना भी x intercept y intercept करें तो फिर आप कोई भी पॉइंट देख सकते हैं जो कि इस इक्वेशन को सेटिस्फाई करता है, लेकिन उससे ये कि आपकी कैलकुलेशन थोड़ी डिफिकल्ट हो जाएंगी. तो आप x इंटरसेप्ट ले लें, y इंटरसेप्ट ले लें, z इंटरसेप्ट ले लें, और वो पॉइंट जिस प्लेन में से फाइंड किया आप उस पॉइंट का दूसरे प्लेन के साथ डिस्टेंस निकालना. ठीक है, फर्स्ट नोट दैट टू प्लेन्स आर पैरेलल बिकॉज़ द नॉर्मल वेक्टर्स आर पैरेलल. ठीक है, ये भी हम देख सकते हैं. नाउ द लास्ट क्वेश्चन, एग्जांपल 3. जी, we showed that the lines L1 and L2 are skew lines. Find the distance between them. Now we have to find the distance between two skew lines. As I told you in the last lecture, that skew lines are those that are not intersecting and are not parallel, and they lie on two parallel planes. That the line L1 lies on the plane P1, suppose, and the line L2 lies on the plane P2, and both the planes are parallel. That's the definition of the skew line. So how to find the distance between two parallel, two skew lines? It means we have to find the distance between two planes P1 and P2, and we don't know the equation of the planes P1 and P2. And how to determine the equation of the planes P1 and P2? क्या डिटरमिन कर सकते हैं इक्वेशन ऑफ द प्लेन P1 and P2? जल्दी से बताएं, टाइम कम है, वरना मैंने आपको दे देना ये क्वेश्चन. Can we determine the equation of the P1 and P2 by the given information?
मैम
Ahmed Faraz, Mudeep.
मैं कह रहा था कि जो लाइन 1 है उसकी वेक्टर पता है मैं 1 3 -1, इसको अगर
हाँ.
नॉर्मल के साथ परपेंडिकुलर होगा.
ठीक है. अच्छा, ये
तो
देखें कि क्या जरूरी है कि दो प्लेन्स की इक्वेशन निकाली जाए, क्योंकि हमारे पास डिस्टेंस फार्मूला में अ पॉइंट एंड अ प्लेन है. तो हम प्लेन P1 में से कोई एक पॉइंट फाइंड करते हैं. we take any point on the plane P1 without finding the equation of the P1. Obviously that will lie on the line L1, and then in the second step we find the equation of the plane P2. यानी P1 निकालने की हमें जरूरत नहीं है, we just find, obviously concept वही है कि we find equation of the two planes because the skew lines lie on the that planes, and then we take any point on the plane P1 and find the distance of that point P from the plane P2. But since we need a point on the other plane P1, so we don't need to find the equation of the plane P1. We find any point on the line L1 by putting, I can find any point on the line L1 or P1. I will put t is equal to 0. The easiest way is to put t is equal to 0. When I put t is equal to 0, then my point is 1, -2, 4. And now I will determine the equation of the plane P2, because now I need this. So how to determine equation of the plane P2? I need a point and a normal vector perpendicular to the plane P2. So the point is very easy. Point is, that is, put s is equal to 0 on the line. Obviously this line L2 is lying on the plane. I will get 0, 3, -3. This is any point on the line plane P2, and any what would be the vector, normal vector? How to find the normal vector? Yes, now the normal vector is perpendicular to this vector 1, 3, -1, and V2 is 2, 1, 4. So the normal vector is perpendicular to these two vectors, and then I will determine the, so I have determined the normal vector n by taking the cross product of V1 and V2. Since the planes are parallel, this is the situation, the planes are parallel. This is the point plane P1, this is the point P2. And to find the normal vector to the plane P2, I have found a vector v on the plane p1 and vector v1 on the plane p1 and the vector v2 on the plane p2, and the normal and vector n is perpendicular to both v1 and v2. Okay, it could be in this direction, v1, not in the same direction, like this. And how I find v1? v1 is because the line L1 is lying on the plane p2 and the line L2 is lying p1 and the line L2 is lying on the plane p2. Okay, and then this is my point on the plane, the other plane, and find the equation of the plane, and this is the, and use the distance formula. Distance formula is the distance between the point and the plane. Okay, any problem in the solution? Very easy, just need a little bit concept, that is what you are doing, and for this you know the concepts of your vectors when they are perpendicular, when they are parallel solutions. That's why I have asked you to revise your concepts on vectors. Yes, students, any question? And now you need to do these questions. So you need to practice 12.1 and 12.5. जी मैम
मैम हमारा सिलेबस खत्म हो गया.
Syllabus I cannot tell you right now. So we have a lecture on Monday. So the Monday's lecture I will tell you about the pattern as well as the paper, and we will see that what we have to do further.
मैम हमारी लास्ट क्लास कब होगी?
नेक्स्ट वीक ही होगी, नेक्स्ट वीक में इंशाल्लाह एक या दो लेक्चर्स तक चले जाएं.
ओके मैम.
ठीक है, तो बस 12.1 12.5 सेक्शन हमने कर लिया और बाकी फिर ये हम करेंगे और
मैम वो बीच में सेक्शन इंक्लूडेड नहीं होंगे फिर?
जी
मैम जो सेक्शन हमने नहीं किए वो फिर इंक्लूडेड नहीं है?
हाँ, वो नहीं है आपके, इंक्लूडेड नहीं है, लेकिन वो सारे यूज हो रहे हैं, इसलिए मैंने कहा था कि आपने रिवाइज करना है. 12.2 3 4 वेक्टर्स की सारी चीजें रिवाइज करनी है. उनके क्वेश्चंस नहीं आएंगे, लेकिन वो सारी चीजें आगे देखती हैं, सारी ही यूज हो रही थी कि वो परपेंडिकुलर है, वो क्रॉस प्रोडक्ट की परपेंडिकुलर है, वो सब चीजें. तो आपके जो क्वेश्चंस आएंगे वो 12.1 12.5 से आएंगे. ठीक है, on the weekend please complete these practice questions, do these practice questions at least, ये देखने के ये क्वेश्चन होते किस तरह से. ठीक है, सॉल्व भी करें और उनको देखना भी, क्योंकि हर क्वेश्चन दूसरे से डिफरेंट होगा. अभी आपने देखा कि हर क्वेश्चन दूसरे से डिफरेंट है सारी एग्जाम्पल जो है, तो इसलिए आपको इसका बेसिक कॉन्सेप्ट पता होना चाहिए कि नॉर्मल वेक्टर है कैसे है, स्क्यू लाइंस कैसे हैं, लाइन लाई कर रही है प्लेन पे तो किस तरह से उसके नॉर्मल वेक्टर की परपेंडिकुलर आ रही है, ये सारी चीजें, इंटरसेक्शन क्या है. ठीक है, सो जितने भी क्वेश्चंस होंगे इससे 12.1 12.5 सेक्शन से वो आप लोग कलेक्ट करके रखें, एंड विल एड्रेस दोस क्वेश्चंस इन माय मंडेज लेक्चर. ओके, यू कैन आस्क मी दोस क्वेश्चंस बाय ईमेल, और यू कैन आस्क मी इन पर्सनल चैट पे भी कर सकते हैं, मीटिंग भी कर सकते हैं इसके ऊपर. ओके, so students, that's all for today's lecture. I will see you the next week inshallah. Allah Hafiz.